now rounding up. We are about to complete it. This is the last chapter we are going to take. In this chapter, we already introduced the chapter and we have treated up to, I think, 22 slides. So we have just like 10 slides to complete the chapter. Okay, so I will quickly go into these sections. I will explain to you, and after that, we will take the last group presentation for this course. So cloud computing trends is a chapter that basically introduces us to new technologies that are coming out of the cloud computing. As I told you in the previous class, cloud computing is actually a technology that also comes out of another technology, which is basically grid computing, or what we can say parallel systems and distributed computing systems. So cloud computing is a technology that tries to give users or clients services based on demand. And we said there are three different types of services that you can get in cloud, which is infrastructure as a service, platform as a service, or software as a service. So these are the three different types of services. In addition, we have the three different models of cloud, which is public cloud, private cloud, community cloud, and hybrid cloud, if you may put it this way. Okay, so these are the things that we discussed previously. But then we are rounding up this course. Therefore, we need to talk about the technologies that come out after the cloud computing. Okay, so in discussing this, we said that there are a number of technologies that comes out after this. One of them is called OpenStack. One of them is called OpenStack. And then we have the edge computing. We have the blockchain technology, and then there's what is called cloud natives. So these are the trends that we are going to discuss in this chapter. However, in the last class, I already discussed with you OpenStack, and I also discussed with you edge computing. So today we will discuss about blockchain technology and native clouds. Now, to go through this, I would like to know what do you understand by OpenStack? We explained it last class, but what is the idea that you picked from there? OpenStack. Do you remember? So basically, OpenStack is a software, okay, that is used to create cloud services and manage cloud services. For example, you don't know how to create a cloud service, but you need a cloud service, okay? You can go to OpenStack. It has different components. Okay, you can download and install it on your device, and then you can create basically a public cloud or a private cloud, and then you can start managing it by yourself. Okay, that's what we use the OpenStack for. So then I go to the next one, edge computing. Who can remember what we said about it? Edge computing. So edge computing is an aspect of cloud computing. It doesn't work by itself. It works together with the cloud, except that it handles cases of or services that are time sensitive, okay, whereby delay is not allowed. We don't want delay. If we allow delay in some applications, it can cause crisis. And I try to give you an example with a driverless car. We now have a lot of driverless cars, right, in many countries. These driverless cars, they communicate with the cloud. But then, sometimes if they communicate with the cloud, it can be a little bit slow. Why? Because everybody around the world is using cloud service. So if everyone goes to the same point to get information, that there will be what? Some kind of congestion, and then it will cause the cloud to be slow. So for this reason, we created like other points where you can be able to access these cloud services. Zainab, you need to keep the phone. Yeah. So you need to create some kind of services, okay, which is called edge computing that will handle this type of cases. If you remember, I give example with, for example, a visa point whereby everybody go to the same place to get a visa. As a result, there may be some delay. Probably you have an emergency and you need to travel. Therefore, you need this visa quickly. So instead of you to go to the same embassy to get this visa, they created another small offices somewhere whereby you can go there quickly and you can get your visa and then you can leave. Why? Because you have an emergency, therefore delay is not allowed. So that's the essence of edge computing. So OpenStack, I mentioned it already. It's just a cloud solution. It's a platform, okay? It's a solution for cloud platform deployment. If you want to deploy cloud services, this is your uh, go-to point. It's open. That's open source. It is flexible and it is scalable. These are the properties, and these are the different types of components. We mentioned all this. It has some components that are called Trove, Sahara, Swift, Celometer, Heat, and so many of them. And this is the relationship between the different components. But when it comes to cloud computing, this is a situation of timelessness. Timelessness means you need to meet requirements for time. We don't need to have a delay. We need to like be fast to execute something. Otherwise, maybe it can cause an accident. Okay, like what happened in the traffic. Okay, if there is a delay in the traffic, it may actually cause accidents. So this type of systems, they cannot afford to use cloud system because cloud system sometimes is a little bit slow because everybody try to access the same service. Therefore, edge computing can be a good solution for this type of situation because edge computing is fast, okay? And then after it completes processing the information needed, edge computing will still have to update this information in the cloud after. Okay? Basically, it will give you anything that you want at the same time, being fast. But after all the execution has been done and you have already achieved what you want to do, it will later on update records in the cloud. Similar to the example I gave for the visa point, if you go to a faster point to do it, after they give you the visa, they still have to update your record later in the embassy. So this tells you that they are not working alone. They still work together with the embassy. So basically, edge computing is not working alone. It still works together with the cloud computing. Okay, so it's just like a new technology that's trying to optimize systems that are basically time sensitive, so that we will not have any issues. So we mentioned these things before, and today we will discuss about blockchain technology. That's the new technology we want to discuss. So the question is, are you familiar with the word blockchain technology? Have you heard of it before? Never? Blockchain technology. Have you heard of this word? Blockchain. I'm not saying if you know the name. I'm saying if you have heard of the word before. You've never heard of it before? Okay. Now I will give you an example and you remember. Have you heard of the word cryptocurrency? Cryptocurrency. Crypto, yes, cryptocurrency. Cryptocurrencies. Have you heard of it? Very good. Bitcoin. Because if you say you don't understand cryptocurrency or you have not heard of it, then I'll ask you the next question. Have you heard of Bitcoin? How about Ethereum? Ethereum is also another coin, just like Bitcoin, right? Now, if you have heard of Bitcoin, what do you think is useful? Is virtual money? Yes, it's virtual asset, just like money. You can spend it, okay? You can acquire it. Now, how do the cryptocurrencies like Bitcoin work? They work based on a technology called blockchain technology. Okay? This is what is used to develop the Bitcoin. Okay? And this technology is a very, very secure and very strong technology. And it is designed based on cryptography. Okay? And some other science that you already know before. Okay? So blockchain technology, also known as distributed ledger technology, is tamper-proof. Tamper-proof, very important word. Non-repudiation, very important word. And it involves multiple parties. Used in conjunction with cryptography, okay? It secures transmission and access and ensures data storage consistency. In addition, it uses what is called blocks validated by others through cryptography, okay, and which is called distributed ledger. Blockchain technology is low cost in computing, meaning it's fast, okay, collaborated paradigm, and is built based on trust. But it's built based on trust and in an trustworthy environment, meaning that it's built based on the internet. Okay. Now, in many countries, cryptocurrency is not allowed, like using Bitcoin is not allowed. Okay. Now the question is, what is even this Bitcoin? How many of you have used the Bitcoin? You have wallets, Bitcoin wallets. People are making money. You are not using it. Why? I'm just joking anyway. So it's not allowed yet in Qatar. Okay, use of Bitcoin is not allowed. But QEC will have to develop a policy. QC and Qatar Central Bank QC will have to develop a policy for it. And in actual sense, Qatar Central Bank is also developing another cryptocurrency based on based on uh, blockchain technology. It will be working similar to Bitcoin, okay? Except that it will be acceptable in the country. So many other countries also are trying to use it. Now, the thing is, if other countries did not use it, people are already accepting it. Now, that takes us back to what is the definition of money? Money is a legal tender that is acceptable. So if people are beginning to accept it, it becomes money. Okay? So that means all countries have to find a way to adopt cryptocurrency technology. Okay? But then, in this class, our main idea here is just to understand how it works, right? So cryptocurrency works based on what is called blocks and ledgers. Yes. So it has what is called distributed ledger. A ledger is just a database, okay, which is shared and it can be replicated and synchronized. I will explain all these things, okay? And it also uses cryptography, like hashing algorithm, okay? And then it uses distributed consensus among participating members or people that are transacting with each other. And then it has what is called smart contract or chain code. So these are all terms that are associated with cryptocurrency that we can use to define it. So this is another slide that try to explain it. So another thing is we are going to take a typical example of what happened if two people are going to make a transaction in the current situation. In the current situation, let's say you want to send me money. Okay, you open the application and you enter the amount and you press send. Where do you think the money, you enter the account number, my account number, and you press send. Where do you think the money goes? If you want to send me money, you open your application, you enter my correct account number, everything, and you put the amount and you send. Where is the money going to?
To the electronic, I know how to say that. I don't know how to explain it.
Yeah.
It's going to the by the electronic transactions.
Yeah.
And then go to the. I don't know.
You tried. Very good. If you send the money, it doesn't come to my account directly. It goes to the bank. Okay? The bank have to okay it before it comes. Okay? So how many people are involved in this transaction? It's three. The sender, the third party, that's the regulator, which is the bank, and the receiver. Okay? So in this case, we have somebody, which is the third party, now the bank, who is responsible for keeping record of all transactions. Okay? If money is missing, the bank will be able to trace it. Now, the problem with this system is that sometimes you want to send the money, the bank is not available. So the transaction will not go through. That's one. You can have a reversal. You send money, it sends, but then later it's reversed. This is another failure of the current system. Okay? Another failure of, I don't know if it's a failure, but some people, they don't want their transactions to be what? To be traced because of the nature of the businesses that they are involved in. So they want a level of anonymity. They don't want to be known that they are the ones that actually carry out this transaction. So if you use banks, they must always know who is involved in the transaction. Okay? If there's anything that has to do with, for example, illicit drugs or buying weapons or something They will know the transaction, they will be able to trace it, they will know who are the people involved. Okay? Now, this is one thing that blockchain technology, such as crypto, try to avoid. Okay? Cryptos works based on what is called peer-to-peer. Only two people are involved, the sender and the receiver. The sending money and receiving. Okay? So, the problem of failure or reversals or tracking of transactions all are not actually involved in this. But then, countries cannot run this way because countries need to know who is involved in what transaction. Okay? But blockchain technology gives level of anonymity. Okay? People carry out transactions without knowing each other. Okay? And the money cannot miss. You send the money, you send a Bitcoin, the person will receive it and pay the money into your account. Okay? If you do receive it, you can actually reverse the transaction and the Bitcoin can come back. So like this. So the reason why it happens this way because it's using a technology that is called a ledger. A ledger is something that keep record of whatever transaction is done. Okay, this is the ledger. Let me show you. It's called a block ledger. So you can see all these are layers. So in this case, for example, you have 1, 2, 3, 4, 5, 6. 6 different people are trying to carry out transactions between themselves. Okay? So let's say, assuming you are one of them. This is what happens if you use blockchain. You have a block, which, for example, you have 100 units of the money, the virtual money. Okay? If you want to send it to another person, let's say this is Mr. B and this is Mr. A. It's not allowed. Legally, in Qatar, it's not allowed. Okay? But it still works all over the world. And the technology is there, so we have to explain it, you know, how it works. So this is what happened. It uses both public and private keys, and it uses also what is called encrypted hash. Okay, that's the technology it's using. Okay, it uses cryptographic algorithms together with a ledger content. This is the ledger. Okay, so basically it uses a private key first. So if you want to send 50 units of the 100 that you have, let's say minus 50. Okay, the moment you send it, you have to use a private key, PR. Okay, and that is what will be used to create what is called a block. Okay, and basically this block is a block that has what is called hashing algorithm. Let's say SHA is what Bitcoin is using. Bitcoin is using SHA 256. That's the name of the algorithm. 256. So your private key will use to encrypt the amount, and the block will use the SHA to create a hash value for it, and then it will be sent as a block. The receiver will use a public key created by you, which is Mr. A. Okay? A public key. Okay? To decrypt, first of all, the hash. Okay? And get the hash value. And then it will use his own private key to decrypt the final value. So Mr. B will receive the final value after the block has been decrypted. But then, the moment Mr. A creates a block, the block is encrypted and is hashed. So the content, which is 50 units of your Bitcoin, is inside an encrypted hash. Okay? The reason why it's encrypted because we don't want people to know how much it is. That's one. The reason why it's hashed because we don't want it to be changed, altered. Okay? So this is the block. So now what happened to this block? It becomes a ledger. This is the ledger. The moment it becomes a ledger, all the participating parties, 1, 2, 3, 4, 5, 6 of them, will receive the same ledger. That's why it's called distributed ledger. They have the amount that you are trying to send, all of them, but they don't know what is inside. Why? Because it's encrypted with a private key and it's hashed. So they cannot also change the content because it's hashed. Okay? That's why it's very secure. Crypto is very secure. It's basically like once it's hashed, that's why it's called shared ledger. All of them will receive the same content of the amount that you are trying to send in a shared ledger, but they don't know how much it is. And they don't know what the content is. And they cannot change the content because it's hashed, right? So this SHA, in the case of Bitcoin, it helps for integrity of the transaction. Okay? It helps the transaction in terms of integrity.
Doctor?
Now,
So the blockchain, and there is no third party in this process,
no,
right?
no third party.
No third party. So that's why it's in Qatar. It's supposed to be between the third party as a bank or the company and the receiver.
Yes. It is blocked not only in Qatar, in many countries. Why? Because the government cannot know the transaction that is happening. And people are using it to buy illicit drugs, buy weapons to carry out crimes and things like that. You know? And even you can use it by VPN, yes. You are trying to expose your brother. And I'm recording. Anyway, I'm just joking. So basically, what happened is that even myself, before I come to Qatar, I have an account, but now I don't know the account again. But then I spent the money already. I've already sold money. Yeah. So basically, what is happening is that it's very secured because you cannot change, and it updates the ledger. All the participating parties will have the same amount. Okay, that's why it's a distributed ledger or shared ledger. But then the transaction can still not go forward until all the participating parties approve it. Once they approve it, then your transaction will proceed. Okay, and the person will accept it, will receive the money, or will receive the transaction. So that's why it's called, but this happens automatically. Okay, it's not that they have to check their account and approve it. No, it just simply check in their account to be sure the amount is within the limit that you have. For example, the example I'm giving here is 50. If you have 50 units, but then you are trying to send 150 units, you don't have 150 units. This transaction will not be approved by participating ledgers. You know why? Because the participating ledgers, they already have your amount before, which is 100 in their blocks. So once you try to send 150, it will check through the blocks for all of them to see if this person, Mr. A, has 150. It will check and it will see that you don't have 150, so it will fail. Okay, but if you send amount that is within the limits that you have, it will check through the blocks. Now, the good thing is if one block is missing, or it fails, or it crashes, your amount still reflects on the others. So you cannot be cheated. Nobody can cheat anybody in blockchain. So this type of algorithm is called consensus algorithm because it makes a consensus within all the participating parties to check, and then it will validate the transaction. If it is okay, then it goes through supervision. Any question? So we have one last slide, and then we take the presentation. The other one is native cloud. Now we know what cloud computing is. Cloud computing is basically a service that provides infrastructure to the users, it provides platforms as a service, and it provides software as a service. These are the most important things. So cloud native is just simply another service that is created within cloud to help cloud to provide more advantage to users. Okay, you want infrastructure, cloud native will try to provide infrastructure for you faster. Okay, you want to create a public cloud, cloud native will help you to provide public cloud faster. So basically, this one is easy. We can go through it quickly. Cloud native started, we already know about this history before. Non-visualization, visualization, infrastructure as a service started 2006. Okay, like this. Then the last one is 2015. That's when we started having this technology called cloud native. Cloud native basically try to give more advantage to users so that they can use cloud services. Okay, so cloud computing is today's IT development, and cloud native is tomorrow's is the tomorrow basically. So as we proceed, technology proceeds, people will adopt more cloud native services because they provide more advantage to cloud than others. So the purpose of using the cloud native, the purpose is to build the cloud model, okay, deploy it, deployment, okay, and deployment in this case is rapid, meaning it's faster, okay. It uses agile or agility, and it's resilient, and it's portable. So basically, it's a type of cloud inside the cloud, but it gives more advantage in terms of usage. So that's what it's used for. And basically, it continuous improvement in terms of feedback and how people use it, okay? So basically, these are the things. So in the native clouds or cloud native, okay, we have development apps, we have what is called microservice, containers, okay. These are some of the components basically. This we can call them product and services. Under platform, we have the containers also, container platforms, microservice framework, and CI/CD tools, which the cloud native uses. In terms of the type of services that we can get computing, storage, and network services. All these are available in the native cloud application. So basically, a native cloud application is an API, which is called Application Program Interface, that gives more services of cloud to the people faster and easier, and take more advantage of cloud services. So that's all about this chapter. Let's answer this question. Which of the following are components of OpenStack? I think we attempted this last time. The answer is all of the above, right? How about this? Cloud native application run on the cloud to take full advantage of the cloud. True or false?